This is the review for 5.1, 5.2, 5.3, and 5.8. We're going to look at determining if this is a polynomial function, and then we'll look at writing it in standard form, doing the degree, the type, and the leading coefficient. Because the exponent is a 1, we know that this is a linear equation. So standard form would be negative 2x plus 7. We're looking at the degree, and the degree is the exponent, so it's 1. The type of equation it is, we know that since it's a degree of 1, it is considered to be linear. And the leading coefficient, in this case, is our slope, so it's negative 2. On this side, we see that our exponents are 1 and 3, so this is definitely a polynomial. So we're going to say that standard form would be negative x cubed, because that's your largest exponent. Then you have your next largest exponent, and then you down to your smallest exponent, which would be x to the 0 power. The degree for this one is your largest exponent. The type, because it is a degree of 3, this is considered to be cubic. And the leading coefficient is, looking at your standard form, it's the number that's out in front, so it's negative 1. The leading coefficient helps us determine which way it's going to progress as x gets larger. We're going to use synthetic substitution to evaluate what is happening with this quartic polynomial, because it's to the 4th power, we call that quartic, when x is negative 1. So on a graph, what's happening when x is negative 1? Where's the y value? Well, we take our x is 1, negative 1. We take all of our coefficients. So we have 6, negative 1, 3, negative 5, and 9. We have to be sure to represent every one of those. That if one of the exponents is missing, then it has to be a 0 at that spot. We bring down the 6 and we multiply, add those together to get negative 7 and multiply, add them together, multiply, add those together and multiply. So when f is negative, or when x is negative 1, we call that f of negative 1, it's going to be 24. Here we're looking at this cubic equation. We want to know what is the y value when x is negative 3. So again, we can use this synthetic substitution. The largest exponent here is 3 and its coefficient is 1. There is no x squared, so we have to represent that as a 0, very important. Negative 8 for the x, and 6 for a constant value. Bring down the 1, multiply, add them together, multiply, add them together, multiply. We got a value of 3 at the end. So g, because this function's name is g, g of negative 3 equals 3. We're going to determine the end behavior of our graph. We're looking here, this is to the 5th, and then the 2nd, then the 1. So we look for our largest exponent. It's already in standard form. So the largest exponent is odd. So we know that the graph is going to go in opposite directions. It's a positive leading coefficient so I know that it's going to increase as x gets bigger. If it's going in opposite directions, that means it decreases as it moves to the left. And in the bottom, it can cross the x-axis up to 5 times. This graph probably doesn't cross it 5 times, but it would do something like that. So that would be once and twice, 3 times, and 4 times, and 5 times. That's approximately what it would look like. If you type that into your graphing calculator, it probably doesn't wiggle through that many times, but that would be a possibility for some sort of x to the 5th power. But that's going to help us notice x approaches positive infinity as the function goes up. X is going to go to negative infinity as the function goes down, approaches negative infinity. On this side, we see our largest exponent is an 8, so it's an even, which tells us that the end behaviors will be going in the same direction. Because the leading coefficient is positive again, I know that they'll both be curving up. A lot of weird things can happen in the middle. It could cross up to 8 times. This graph probably doesn't do that. But when x gets really big, I know the function is getting really big. And when x gets really small, I know the function is still getting very big. Here we're going to try to simplify. We see that we have a 3. We have common bases. So we could say 1 minus 2. That's going to give us 3 to the x negative 1. So we have 3 on top and x on bottom. Take a look at what we have here. We have 1x on top. We have 2 x's on bottom. There's more x's on bottom than on top. There's 1 extra on bottom, so of course the x is going to be on bottom. The 3 is not attached to it. Over here, we can reduce this first fraction if you would like. 2 goes into 4 twice. X to the 4th and x to the 3rd. There's more x's on top. There's an extra x on top. There's an extra y on bottom. The 3 and the 2 cannot be reduced. There's an extra x on bottom, and there's 2 extra y's on top. 3 minus 1 would give you 2, and it would stay on top. Then we can come through and we can multiply, or maybe we would just rather reduce. Our x's can reduce. One of our y's can reduce with one of those, so we're left with 3 and a y. You can clean up the inside first and then work with the exponent, or vice versa. I'll do the inside first. I see that I have a 3 and a 2. Neither of those can go anywhere. I have an x squared with an x to the negative 2, means it's also going to be on the top with a positive exponent. There were 2 extra y's on top compared to the bottom. So now I'm going to take my negative 2 and I'm going to distribute it over to the exponent and get 3 to the negative 2. This would be 4, so this is x to the negative 8, y to the negative 4, and this would be 2 to the negative 2. So our final answer, 2 squared would come up on top to be 4. 3 squared would go on bottom to be 9. X to the 8th and y to the 4th would be in the denominator. With this one, we see that the 2 has a negative exponent, so it goes to the denominator. The x has a negative exponent. There's already an x squared down there. There's already a negative 3 down there. There's more y's on the top than there are on the bottom. So we're going to have a y on top. 4 times negative 3 is negative 12. Notice that that's a positive exponent, so it doesn't have to move. And then we have 5 x's. Working with scientific notation, we're going to multiply the 2.2 times the 1, and we're going to multiply the 10s together, so we add exponents. So we get 2.2 times 10 to the 11th. Here we have the 3.2. We're going to multiply that with the 2. We have the 10 that's multiplying the 10, so we add exponents. So we're going to get 6.4 times 10 to the 2nd. On this side, we're going to take the 4.2, times that by 3, take the 10 and multiply the 10, so we add exponents. That's going to give us 12.6 times 10 to the 5th. Now notice that the 12 is greater than 10. This value has to be between 1 and 10. It has to be less than 10. So we're going to move our decimal spot over, which is going to make this one larger. If in this case we had to move over 5 times, if we move the decimal and start it from between the 1 and the 2, then that would be 6 times to get over to where we needed. Here we're going to give our answer in scientific notation. We have a local baseball league that has 1,000 players. In the first hour of baseball, each of these players are going to throw the ball 102 times. They practice for 2.5 hours. So we could say 102 times 2.5. That's going to give us 255 pitches or throws in a single practice. And we're doing that for 1,000 players. Okay, we're going to do that 32 times during our season. There must be like 32 practices. and we're going to do that for 18 seasons. So if we were to write this in scientific notation, we get 1.4688 times 10. 1, 2, 3, 4, 5, 6, 7, 8 to the 8th. That's how many pitches or throws that there would be. Looking for the sum, notice that this has a plus in between. So we're going to take our 3x squared, our negative 4x, and our 2. And we're going to add it to our negative 2x squared, our 8x, and the 14. So we group our like terms together, which is going to give us 1x squared. The x's are going to give us 4x, and the constants are going to give us 16. On this side, we need to distribute our negative through. So we're going to take 3x squared, negative 4x plus 2. We have a positive 2x squared, a negative 8x, and a negative 14. That's because we distributed the negative through. Now we collect our like terms to get 5x squared. Our like terms to get negative 12x, and to get negative 12. Here we're multiplying, so we're going to take our x and multiply it to all three pieces. So we get 4x cubed and 2x squared minus 3x. Then we'll come through and do it with the 5. It's a double distribution. So we're going to get a 20x squared, a 10x, and a negative 15. So that's giving us 4x cubed, 22x squared, plus 7x's, negative 15. If we're going to expand these, this looks like a perfect square. And our pattern here that's what a perfect square trinomial would look like. So we're going to take our a value and square it. We'll take 2 times our a and our b. Then we'll take our b value and square it. So we can do that without foiling it together. We use the pattern of a perfect square trinomial. This is our cubic, okay, a perfect cubic. So we're going to start with 1, 3, 3, and 1. Put our a value cubed, our a value squared, our a value to the first power, and then our a value to the 0 power. Then we put our b value to the 0, our b value to the first, our b value to the second, and our b value to the third. That's going to give us 27x cubed. That'll give us 9 times 4 times 3, which gives us 108. That would be x squared. This is going to give us 16 times 9, which is 144. and our x, and then 4 to the third power is 64. In this case, we'll start out with our 1, our 3, and a 1. Our a value is 2x squared, and that's going to be cubed. Our a value is 2x squared, and that'll be squared. 2x squared to the first power and 2x squared to the 0 power. Then we'll take our b value to the 0 power. Our b value, which is negative 3, to the first power. Our b value, which is negative 3 squared. And then our b value, which is negative 3 to the third. So this is going to become 2 to the third power x to the sixth. This will become negative 9. 2 squared is 4, x to the fourth. This will become 9 times 6 with an x squared, and 3 to the third power is 27, and it'll be a negative 27. So we're going to get 8x to the sixth minus 36x to the fourth plus 54x squared minus 27. Notice how we did this without setting them all out and doing a FOIL and then another double distribution throughout it. There's a pattern. You can do it either format, but the pattern's kind of a neat way to see it. Number 21. We look at the pattern that they have here. It's not a perfect square because they're a little bit different from each other, but if you notice, you have the 4x and you got the 5's. You got a plus or minus in between. So I know that this is 4x squared and it is 5 squared. So this is 16x squared minus 25. You could go through FOIL and you could produce the same answer. Your middle terms would cross out. But essentially, there you go. Here we're looking at the volume. We know volume equals length times width times height. So the volume is going to be x plus 6 times x times 2x plus 1. So the volume is going to be, multiply this guy in here, x squared plus 6x, and I still have to multiply that to 2x plus 1. So multiply the first terms to get 2x cubed plus x squared plus 12x squared plus 6x. That leaves us with 2x cubed plus 13x squared plus 6x. That would be in standard form. Okay, we're going to graph this guy. We're going to make a table. I'm going to use this area for my synthetic. So I'll make my table over here. My x and the y. When x is 0, I know I'm going to get 1. That's my y-intercept. When x is negative 1, plug in my negative 1, a 2. I don't have an x squared, so that's got to be my 0. Negative 5 and 1. Just doing our synthetic substitution. So at negative 1, I'm getting a value of 3. At negative 2, at negative 2, it looks like we've dropped way, way down low. This is a cubic equation, or to the 4th power, so it will be pointing down at some point. Let's start to look to the right and see what happens. When x is 1, we're down at negative 3. When x is 2, we're down at negative 9. Okay, I know that this can cross up to 4 times, so I'm expecting this to do another curve up and another curve down somewhere. Just because it's to the 4th power doesn't require it to cross 4 times. So that would be negative 42. And when we add 1 to that, we get negative 41. So this just happens to be a real funny one. It comes down. And our equation is h of x equals negative x to the 4th plus 2x cubed minus 5x plus 1. Just the way the numbers are laid out, it doesn't have 4 different factors, so it doesn't come through and cross 4 different times.